So this is the second part of the second module, and it deals with quality of evidence. Actually, it comes after the part on study designs and before the third part, which is how to summarize and assess quality of evidence. Now, in this rather short PowerPoint, we will define the different study designs and understand the sources of bias. We'll assess the hierarchy of evidence and understand the main approaches used to assess study quality. Now, before we dive into the quality of studies, there are three important elements you need to understand well to assess quality of evidence and quality of study. The first one is confounding. The second one is random error, also called chance. And then the third one is bias, it's systematic error. Now, I have included a video, and you will find a YouTube link in the comments below this PowerPoint from Cochrane, Austria, that explains these three different concepts. You need to watch the video and study it well, because these three elements, so confounding, chance, and bias, are really at the heart of any approach to assess study quality and quality of evidence. And I will not explain it again because the video explains it pretty well with a number of examples. So have a look at the video to understand confounding, chance, and bias. There are three concepts that will reoccur during the discussions and that you should understand carefully to understand the next part of the class. Let's start with bias. Also explained in the video, bias is systematic error. It is a systematic departure of the true value. So it is something that is introduced to the study. It's not a random error that is unavoidable. This is systematic error, so something that we haven't measured properly, or something in the study design that takes it away from the true value. And throughout the next slide, I will show you an abstract, and then we can reflect on the main sources of bias in nutrition epidemiology. Now, there are many sorts of bias. There are many places where bias can occur, and to help researchers define these sources of bias and also to develop tools to assess that bias, the University of Oxford has developed a catalog of bias. And so this database actually contains all sorts of bias and how they are defined. So whenever you need to go back to bias and understand what is clearly meant, you can go there and you can see the different terms used. We'll come back to that a little bit later. So on this abstract, I give you an example of nutrition epidemiological study, and then you can reflect on, what types of bias are present here or are potentially present. Have a look at it, and I suggest you pause the video now to think about this and come up with a number of biases that you identify here. I will just introduce some concepts a bit later on. Okay, so what you see here already is, I give you a couple of examples. There is a selection bias because only the volunteers took part in the study, and we know that the volunteers are typically the more healthy ones, the more willing to participate in these trials. So they're very different than the general population in this study. They're possibly also the ones that already exercise a lot more or have a lower cardiovascular risk. The history, maybe that's also a recall bias, so people have difficulty recalling their history. Routine health records, that is also a potential source of bias because those registering that data may not have the right accuracy or may not have registered that data for research purposes. And there's also an effect of confounding because, the smoking is actually a confounder in the relationship between exercise and cardiovascular risks, because those who exercise possibly smoke less, and we know that smoking is associated with cardiovascular disease. So it meets all of the criteria for a confounder. Bias actually can occur throughout the whole study cycle. So from how you've consulted sources of literature, you have selected a database that mainly indexes journals from a discipline or with a certain language, or has only papers that are published open access, or the more recent ones. So that's a source of bias. The study designs may be a source of bias, looking only at observational studies or only at trials, may introduce a bias. How studies are executed, were they implemented properly, were people randomized to the groups, were the quality assured, how was data collected, how was data analyzed, interpretation of the results, and the publication bias. We'll probably go back to publication bias later. An example here is that only studies with positive findings are published, and ones with negative findings or no findings rarely meet it to publication because of many different reasons. Authors may not submit it, or journals may not be very interested to publish these results. Right, I have a couple of slides with some examples of bias from this catalog of bias. Have a read through them. Of course, you don't need to study every bias in detail with their definitions, but I think it's important that you have a feel of where bias can occur and how that bias is classified. Voilà. One type of bias that I wish to explain is the Hawthorne effect, and it is the fact that people may change their behavior when being studied. So when you take part in a study and when people are looking how you behave, you're prone to change your behavior. And this Hawthorne effect was studied in an electrical company where they wanted to study the effect of the light intensity on the productivity of the workers. And in fact, what they saw is that workers had changed their productivity even in the control departments where no lighting was changed. So in fact, because they knew they were being studied, they actually were more productive. So that's called the Hawthorne effect. So people will change their behavior because they are being studied. Okay, so bias enters studies at all stages and often influences the magnitude and the direction of results. It can go in any direction, actually. It can be more favorable to a larger effect, or it also be to more negative effect or a null effect. There's very little you can do apart from executing the study properly, acknowledging the sources of bias, and trying to limit them as much as possible. It's almost impossible to rule out all bias, but researchers are responsible to acknowledge the potential sources of bias and take all possible steps to avoid and minimize their effects. Now, of course, when it comes to interpreting the effects of the study, one needs to be knowledgeable of potential sources of bias and interpret the finding in that context. Do you think that finding is an overestimation, an underestimation? Is that a correct inference from the study results, or do you think the possible bias may actually jeopardize the validity of the results? So that is important that once you read the findings and the study designs, that you try to interpret the findings according to these sources of bias. Okay, we'll move to the hierarchy of evidence. But before we do that, I want to show you the Bradford Hill standards for inference and causality, because it's not because studies are higher on the ranking of quality of evidence that they lead to a more causal effect. There are important criteria to assess causality, and Bradford Hill has proposed 9 standards that one can use to assess whether there is a causal relationship, and in this case it's between the exposure and the outcome. One of the effects would be the strength. So is there a strong and a large effect size between the exposure and the outcome? If there's a strong effect size, one would be more confident to assume causality. Is there consistency? If you do different studies, do they all lead to the same finding? Do they confirm each other? Or is there really a large difference in how studies have looked at the causal effect? So one study leads to a positive finding, the other to a negative finding, the other to a null finding. Is obviously a little bit more, one would be a little bit more cautious to assume causality compared to studies that have all come to the same conclusions. Specificity is the effect that you see specific to the effect to the relationship that you see, and are the criteria that you've mentioned, are they really correctly measuring the exposure and the outcome? I'm just giving an example. If you measure dietary exposure, did you really measure what people were consuming, or did you measure what they were purchasing or what they were saying they consumed? And the same goes to the outcomes. If there's a cardiovascular risk, did you measure the risk, or did you measure a reported risk or a biomarker that has an unclear association with that risk? Temporality is a fourth criterion, which means that one needs to occur before the other. So the exposure and the outcome are not occurring at the same time. So the exposures occur first and then the outcome. It's obviously a lot more, one is a lot more confident in the causality if the exposure occurs before the outcome. The fifth is the biological gradient. Is there a dose-response relationship? In other words, that means if the exposure increases, will the outcome also increase? With the conclusion that you will assume a larger causal effect if there is a dose-response relationship. So if the exposure increases, that also the outcome increases. Is there a mechanism that one can infer? Is there an explanation for these associations? Because, epidemiological findings can be statistical. So if there's no plausible mechanism how an exposure would lead to an outcome, that's obviously a lot more problematic than when there is already a clear mechanism hypothesized. Are the lab findings and the epidemiological findings coherent? Do they say the same things? If the epidemiological studies confirm the lab findings, obviously that's a lot more reassuring than when you find differences. If you can actually compare the findings, so I'm now at number 8, between an experiment and an epidemiological study, that is also another criterion. It's a bit overlapping with concept 7, to be honest. And number 9, if there are other mechanisms documented in literature. For instance, if you see, this compound has led to this cardiovascular event, and if you know of other compounds that have produced the same effect. So if there are similarities with other exposures and outcomes. So finally, we end up with a hierarchy of evidence with the different study designs, and the higher these study designs are in the pyramid of evidence, the more we consider them of higher quality for a strong epidemiological effect. So at the bottom you have the expert opinions, and then you move up with the observational studies, case reports, case series, case control studies. Actually, the cross-sectional studies are missing here. So they should be in between case reports and case controls. Then you have the cohort studies, we've discussed them at length, and then the randomized controlled trials. These are all considered to be unfiltered sources of information, so you execute the study and you publish it. Whereas at the top of the pyramid you have the filtered information. So you have there the studies that were assessed by other researchers. So these are obviously considered to be a higher quality, because these study findings are are being assessed critically by another person. So that person will look at the quality of the study and the quality of evidence. And there you see critically appraised topics. So this is more of a narrative reflection on the study. And then at the very top of the pyramid, we go to systematic reviews and meta-analysis. Again, meta-analysis only when it's relevant and possible. This is conducted. So not always a meta-analysis will be conducted on a systematic review because it's simply not a good idea. Now, how do we assess quality of evidence? Actually, there are tools to assess that. But one important requirement before we can assess quality of evidence is that there are a completeness of reporting. So it means that the research findings are, in that sense, complete, that everything is mentioned in that study report that is necessary to assess the quality. So just to make sure people who are writing up studies don't forget to put things, there are a number of reporting guidelines developed. For observational studies, this is the STROBE statement. The STROBE stands for Strengthening the Reporting of Observational Studies in Epidemiology, and there is also a specific guideline for nutrition studies. So this means if you're writing up a case control or a cross-sectional study or a dietary assessment study, you could use these reporting guidelines to remember to put all the details. So later on when people assess the quality of your study, they can actually understand what you've done. For randomized controlled trials, we have the CONSORT statement and also the CONSORT net statement that is under development. So that is not available yet, but should be available somewhere in 2025. So the CONSORT net will be a reporting guideline for trials in nutrition. For systematic reviews, we have the PRISMA statement or the MOOS statement, of which the PRISMA statement is the most common one. So the PRISMA statement is a guideline for people to report randomized systematic reviews. So there you'll find all of the details. The MOOS statement is sometimes used also for meta-analysis, if I'm not mistaken, but more commonly the PRISMA is the one that is used. So you may remember to use these tools when you're writing up your study findings, for instance, during your master dissertation. Right. Once you have ascertained that there is reportness of completing all the things I mentioned in your study designs, you can actually use tools to assess quality of studies. So for different study designs, there are tools available for use, but there's no real consensus. When you read through the literature, you'll find that authors have used different study designs and different tools related to these to assess the quality of these studies. So the tools I am showing you here are widely used tools, but they are not the only tools that are available. And so sometimes people use other instruments. So for observational studies, you have the 3 observational studies there. There is one set of tools for randomized controlled trials. There's another set of tools, and for systematic reviews, there are also tools. So for the observational studies, the tool that is proposed here or that you can apply is the one by Hoy et al., which is shared under your Euphora folder. Whereas for the cohort studies and the case control studies, we typically use the Newcastle-Ottawa scale. And so the criteria that you mentioned here are the ones that are checked and asked for by the Newcastle-Ottawa scale. To give you an example, when you assess the quality of a cohort study, they will see how the cohorts are selected, how the cohorts were comparable, how the outcomes were assessed, the case control studies. They will look at how the cases will match to the controls, how the exposure were assessed, and all of that. There are other criteria and more detailed questions below them. For randomized controlled trials, there are we typically use the Cochrane Bristol bias. So I explained it in the class. The Cochrane is a collaboration where you can find a lot of guidance, instruments, and tools to conduct randomized controlled trials, but also to summarize their evidence. And so the domains that are assessed for a risk of bias is the bias that arises from the randomization process. So was that randomization was that done properly? Were there any deviations from the intended intervention? So was the intervention executed as planned? Were there any missing outcome data because maybe participants have left the trial or measurements weren't taken? Any measurement in the outcome? Was the outcome properly measured at the right moment with the right sensitivity? Any bias in the selected reporting of the results? So did the authors actually publish what they were intended to examine, etc. So these are the domains for the Cochrane risk of bias. And for the systematic reviews, we use the AMSTAR statement. And I'm not going to go through all of the criteria here. You see them on the screen. The most important element here is that you use an AMSTAR statement, that you read the different questions and you go through each of the different criteria and assess systematic review. And then I think you will understand why these questions are asked. We will come back to that in the class of food and nutrition epidemiology, where I also will ask you to apply the AMSTAR checklist to a systematic review to prepare a policy brief. So that's in the second year that we will apply that to. So these are the other criteria in the AMSTAR checklist. Now, eventually, when you have compiled your sources of evidence, you will make a judgment about the overall quality of evidence. I will come back to that in the systematic review of evidence and the summary of evidence. In brief, I will already explain it here. The GRADE working group has proposed a rubric to classify evidence into 4 categories: high quality evidence, moderate quality, low and very low quality evidence. Now, how does one get there? If your study is assessed on a randomized controlled trial, we start with high quality evidence because we consider randomized controlled trials a better quality of evidence to assess the relationship between an exposure and an outcome. So we start with the high quality evidence, and then there could be reasons to downgrade that quality of evidence. If there are high risk of bias, if there's an inconsistency, if there's an indirectness, imprecision, and publication bias, we will downgrade that quality of evidence. You can go down 1 or 2 categories. So from high, you can drop to moderate and low if you consider there's a problem in each of these categories. But there's also a reason to go up if there's a dose-response relationship, if there's a large effect, and if all residual confounding has been assessed. You see, like, okay, these trials have assessed all possible confounders, then we can up the quality of evidence, and we finally land at one of these 4 categories. So you may say, okay, we start with a randomized controlled trial, we start with a high quality of evidence. I consider there is an inconsistency in the finding, I will drop to moderate, but because there's a dose-response relationship, I will end up with high, as an example. If you have non-randomized studies, so observational studies, you start lower. You have a low quality of evidence, and then you have the possibility to up or also to downgrade your quality of evidence to also arrive at these findings. So then this is how we assess the overall body of evidence when we are summarizing review when we're summarizing evidence on a particular topic. So, what is the difference between these tools? Just as a short recap, maybe you pause the recording and try to come up with an explanation yourself. So in brief, Strobe and Newcastle Ottawa are tools for observational studies. The Strobe statement or the Strobe NUT statement is a reporting guideline. They try to make sure everything is mentioned in the paper, whereas the Newcastle Ottawa scales are a tool to assess quality of studies, especially for case controls and cohort studies. The PRISMA and the AMSTAR are for systematic reviews. The PRISMA is the reporting guideline, so it helps authors to make sure everything is in their paper. The AMSTAR checklist is a checklist to assess the quality of a systematic review. How well was that study conducted? Thirdly, you have the consort statement. That is for clinical trials. So consort and the forthcoming consort nutrition are reporting guidelines. They help authors to make sure everything is mentioned. And then the risk of bias studies is actually the tool to assess the quality of a randomized trial. The grade here is a rubric to assess the quality of evidence. It's typically associated with systematic reviews, and it goes through different study designs and reasons to up or downgrade the quality of evidence. That's it for this slide. I hope it was useful. Please contact me if you have any need for information.